Okay. Hello guys to the third week of our Python programming class. Let me just share my screen now. All right. So let's do a quick refresher from the last class. Last class was mostly about basics of Python and using some of the math functions in Python, like percents and square roots and modular arithmetic and what have you. And the homework from last week tested you on using some of the math stuff in Python, especially the geometry functions. So I'll post the solution to the last homework in the coming days. And if you guys have any questions about the solution, you could always contact me. But yeah, are there any? So does anyone have any questions about what we went over last week? Oh, all right. So the focus of this week's lecture will be on how Python does randomness, or more specifically, the random module in Python. So the module in Python called random offers a suite of functions for generating random numbers. Functions in the random module depend on a pseudo-random number generator function, random, that's called random, which generates a random float number between 0.0 and 1.0. So we're going to I'm going to show you guys what the random function looks like. Let's see if I can make the text a little bigger. All right, so the first step is to import random. So this will give us access to some of the random, some of the methods in Python for doing randomness. And we're going to print out a random number using the random.random function in Python. We're going to make sure that we're going to run basic code. Go current file. All right, and we see our output here. So the random function, this random right here, this outputs a random number between 0 and 1. So right now we got 0.61. If I were to run this again, I'd get 0.62. This is completely random. Run this again, we get 0.95. Or if I run this again, we'll get 0.76. So it's always going to be a random number between 0 and 1. That's how the random function in Python works. Now, from what we just saw earlier, random always outputted a random number, but there's a way to add some consistency to Python's randomness. So in this slide, I'll be talking a little bit about that. So the seed method is used to initialize the random number generator. The random number generator needs a number to start with, a seed value, to be able to generate a random number. By default, the random number generator uses the current system time. The version specifies how to convert the a parameter into an integer, and the default value is 2. So this is the random. This is the seed method. It takes two arguments. The first one is an integer a. Is it an integer? Yeah. It takes an argument a and then a version number and then a version. So we'll talk about both as we use the random.seed function. So it says here, use the seed method to customize the start number of the random number generator. Note, if you use the same seed value twice, you will get the same random number twice. See the example. So let's run this code here. All right, so let's talk about what this does. So first, in this line, we are setting a random seed with random.seed, and we're passing an integer 20. And then we print a random number. And then we set the random seed again to the same number, and then we print a random number again. Let's see what we get when we run this code. And as we can see here, we get the same random number twice because we use the same seed. And if I were to change this to a 21, actually, I'll ask you guys. So what do you guys think will happen if I were to change the random seed to 21? Are we going to get the same number, 0.90, or will we get different numbers? Oh, let's see. Okay, let's run this code and see what happens when we change the. Oh,
I think different.
Okay. All right. So let's see what happens. So yeah, we do get different numbers. Okay, now I have another question. What would happen if we were to change the first random seed to 20 and the second random seed to 21? Are you going to get the same numbers like this, or will they be different?
Different.
Okay. Right, let's see what happens. And yep, they are indeed different. And if I were to run this code multiple times, we're always going to get the same random number because we use the same seed. Now that is the purpose of the random seed. Just run this a bunch of times, and again, I'm getting the same number every time. So that's how the random seed works. Now we have another random. Now we have another function in the random Python's random library. So we have random.randint. So what this does is that it returns a random integer between the specified integers. So for example, this one here returns a random number between 1 and 200. Let's run this and see what we get. Oh, I didn't print it. Oh, let's see. All right, so we get 45 when we run this. If we run this again, we'll get 168. If we run this again, we'll get 97. Now I have a question for you guys. What is the difference between the random, actually, I'll print both out, but maybe it'll make things easier. Okay. So here's my question for you guys. What is the difference between the random.random function and the random.randint function? There's a difference between the two, random.random, random.randint. Well, the difference is that random.random returns a random number between 0 and 1, and random.randint returns a random integer between the two numbers that the user specified. So if I were to change this to 150 and 2000, would it be possible for me to get a number, say, that's like 30? No, it would not, because it's smaller than 150. If I were to run this, I'd get 1,423, a random number, because that's what I specified in the arguments for random.randint. So that's how it works. Are there any questions about what we've gone over so far? Is everyone understanding this? All right. Now we have another function, random.randrange. It returns a randomly selected element from the range created by the start, stop, and step arguments. The value of start is 0 by default. Similarly, the value of step is 1 by default. So let's figure out what this means. So we have a start, which in this case is 0, a stop, which is 101, and a step, which is 10. So this means that we're always going to get a number between 0 and 101, but they're going to be in steps of 10. That's essentially what it means. So if we were to run this a few times, we get 10. If we were to run this again, we'll get 80, and then 0, 0 again, get 80 again, we get 50, we get 60, we get 70, 60. So are you guys noticing a pattern in the random numbers that we're getting when we use random.randrange? Can you guys tell me what pattern that you're noticing in the bottom here?
They're all multiples of 10.
Yep. And why are they all multiples of 10?
We have their numbers 0 and 1 with a skip counting almost of 10 units.
Yep. So they're all multiples of 10 because that's what we specified in our step right here. And they're all between 0 and 101 as well, because that's what we specified with these first two arguments here. So good job, Ivy. All right. We have another function, random.choice. Random.choice returns a randomly selected element from a non-empty sequence. An empty sequence as an argument raises an index error, which pretty much means that you can't pass an empty sequence to random.choice. So to reiterate, random.choice just returns a randomly selected element from the sequence that you give it. So if we were to run this, I'm given random.choice as a sequence of 42, 63, 45, 87, 65, and 41. So if you were to run this, we'll get 41 down here, which is a number in the sequence. Run this again, we'll get 41 again. This time we got 87, which is in here. 63, which is in here. Let's run this one more time. 45, which is in here. So, yep, that's how random.choice works. You give it a sequence and it gives you a random number in that sequence. Now let's see. The choices method returns a list of randomly selected elements from the specified sequence. You can weigh the possibility of each result with the weights parameter or the cum weights parameter. The sequence can be a string, a range, a list, a tuple, or any other kind of sequence. So the choices method is pretty much like a more sophisticated version of the choice method that we just demonstrated. So random.choices takes a sequence. It can take weights, which is pretty much the probability of each element in a sequence being chosen. It can take a cum weights, and it could take a k, which is the length of the returned list. Yeah, and only the last three arguments are optional, so you don't need to put anything for them. And I'll show you guys some examples of what I mean. So let's create a list with some fruits in it. We have apple, banana, and cherry. And let's see what we're going to do with this list. We're going to pass to random.choices my list, which is apple, banana, and cherry. We're going to pass some weights to it. So the first element was apple is going to have a weight of 10, and the rest will have a weight of 1. And we're going to pass k, which is equal to 14. So let's see what this does. All right. Okay. And we got a lot of apple. We got some cherry in here. So can you guys all see the output of this okay? Right.
Yeah.
Okay. So can one of you guys try to explain to me why we're getting the output that we're getting? Okay. So we're getting a lot of apple in the output because apple has a weight of 10, while the rest only have a weight of 1. So that makes apple more likely to appear in the random number generator. And we have k is equal to 14, which makes it so that the random number generator makes 14 choices, which is why we have 14 items in our output. So I have another question for you guys. What do you think will happen if I were to change the middle argument, in this case, banana, if I were to change the weight to 10, and I'll change the weight of apple to 1? What do you guys think will happen?
Banana will appear more.
Yep, exactly. Good job, Austin. And that's exactly what happened. We have a banana appearing a bunch of times. Now I have another question. What happens if I were to change all of these to 10?
They'd all like appear. Then they would all appear like the equal amount.
Yep, that is correct. I think you and Henry, I think you were about to say the same thing too. So yep, as we can see here, they all appeared about the equal amount. So yep, good job for getting that. So that's how the random.choices method works. So next we have random.shuffle. This function randomly reorders the elements in a list. So let's copy all of this. So we're creating a list called numbers that has some integers in it. And then we use random.shuffle on this list of numbers. And then we print it out again. So if we were to do this, we can see that in our output, the ordering of the numbers is different than the ordering of the numbers than how we declared it how we originally declared it. The ordering is different. So it's a pretty straightforward function. If we were to run this again, we'll get a different ordering. So this time we have 45 and then 43 and 12. If we were to run this again, we'll get 12, 65, and 43. If you run it again, it'll be shuffled differently. So that's how shuffle works. Now we have the sample method. The sample method returns a list with a random selection of a specified number of items from a sequence. The selection it returns does not include duplicates. This method does not change the original sequence. Pay attention, size is required, and it cannot be bigger than the size of the sequence. So let's try random.sample out. Actually, but before that, I will do a little bit more talking. If you want a sample of a range of numbers, you can use the built-in range, which takes a start, a stop, and a step to return a sequence of integers. Start, stop, and step must all be integers. The default value of step is 1, and the default value of start is 0. So using sample and range in conjunction, we could get a random sample of a sequence. And I'll show you guys what I mean by that. All right, so let's break down what I just copied here. We have random.sample, and we're passing it, and to it, we're passing this range method. Oh, oops. So with range, we are, I think, so with range, we are starting at 0, we're ending at 100, and we're going in steps of 5. So in the end, this will create a sequence that looks something like 0, 5, 10, 15, 20, 25, all the way up to 100. And then with random.sample, we take a random number in that sequence. So let's run this and see what we get. Oh. Oh, okay. Actually, I see what happened. Okay. All right. So to correct myself a bit from earlier, so sample takes 2 arguments, a sequence and what else? A sequence and a size. All right. So with this, with the range function, we're creating a sequence of numbers from 0 to 100. So this was the result that will look like 0, 1, 2, 3, 4, 5, all the way up to 100. And then with 5, we are taking 5 random numbers from that sequence. And that's why we're getting 5 random numbers here between 0 and 100. If I were to run this again, I'd get a different set of 5 numbers. If we run it again, we get 5 more random numbers. So just random numbers. Now I have a question for you guys. If I were to change the range to 0, from 0 to 100 to 0 to 1000, and I were to change the size to 8, can you guys tell me what my output would look like? Okay, so in short, we're going to get 8 random values between 0 and 1000. So that's what's going to happen. If I were to run this, that's exactly what happens. We're getting a bigger numbers in between 0 and 1000, and there's going to be 8 of them. Let's see. What else do we have? And there are some other functions in Python's random library that you guys can go through on your own time. I'll post a link to this in the chat, and I'll also try to post this in the Google Classroom too. Actually, let's take a quick look at it. So we see random.seed here. I gave an example of this earlier. Let's see a function that we didn't go over. Let's see, we didn't go over random.bytes, I think. So rand bytes just generates n random bytes. So this page has a number of fun functions for doing random number generation in Python. Okay, now we have some exercises. So let's see, first exercise, before I get into the exercises, can you guys tell me if you have any questions or comments about what we've gone over so far? All right. So our first exercise, use random to generate 3 random integers between 0 and 100. Right, so let's do this part first. Use random to generate 3 random integers between 0 and 100. So can you guys maybe try to tell me which of these functions that I should use to generate 3 random numbers between 1 and 100? Three random integers, actually. Right, it looks like that we should use the random.randint function that I demonstrated a bit earlier in the class. In the class, so we want between 0 and 100. So let's change the numbers here. And we want 3 of them. So I wonder if this will print out 3 if I were to add the 3 there. Let's see. Or okay. Okay, so what we can do is just assign, so just run this 3 times with like A, B, and C. So we have a variable called A, that's 1, and then a variable B, that's also another random number. And then C is equal to another random number. And then we could print A, B, and C. Let's see what we get. We get 3 random numbers. All right. So we have generated 3 random numbers between 0 and 100. Now the next step is to use math to find the square root of each number. And remember that it's the math.sqrt function that returns the square root of a number. So what we need to do first is import math. Now, can you guys tell me what I should change for an A, B, and C in order to get the square root of these random numbers? Should probably be printing something else out, but what should I be printing? I should have something in each of these math.sqrt function calls right here, but what should I put in them?
Variables.
Yep, we put A, B, and C. Good job, Ivy. So if I run this, I get the square root of 92, which is 9.59, square root of 52, which is 7.2, and the square root of 86, which is 9.2. So if I were to run this a few times, we'll get different random numbers. So, yep, that's the first exercise. Right now we have a quiz. So for this quiz, we have a string called pi native. Now the question is to choose the correct function to pick out a single character from a given string randomly. Our choices are random.sample, random.choice, or random.get. Can you guys tell me what function I should choose? All right. We have someone saying B. Let's see if that works. Random.choice. So let's see if random.choice gives us a random character from the string right here. And it looks like it does. Yep. Yep, and so we got E this time. This time we got B. This time we got A. So we're getting a random letter in the string every single time. So good job, Henry. Okay. Here's another quiz. Choose the correct function from the following list to get the random integer between 99 and 200, which is divisible by 3. So our choices are rand range, rand int, or random. Can you guys tell me which one is correct? Yep. We should be choosing rand range, because remember that the rand range function takes a start, which is 99, a stop, which is 3, and a start, which is 99, a stop, which is 200, and a step, which is 3. So because of the step here, our random number will always be divisible by 3. So rand range is the answer to the question. And to prove it, let's just run this quickly. So if I were to run this, I'm always going to get a number that's divisible by 3, so like 156, 147, 105, 108, 106. They're all divisible by 3. And if you guys want a really handy way of figuring out if a number is divisible by 3, you can just add up all the digits, and if the digits add up to a number that's divisible by 3, that means the whole number is divisible by 3. So in this case, 1 plus 0 plus 5 is 6, and 6 is divisible by 3. If we run this again, we get 126. So 1 plus 2 is 3, and 3 plus 6 is 9, which is divisible by 3. Run this again, we get 1 plus 6 is 7, 7 plus 8 is 15, which is divisible by 3. So this will be helpful in your SATs when you eventually take them, if you take them. Anyway, I was getting a little sidetracked. Next quiz. So the random.seed method is used to initialize the pseudo-random number generator. The random module uses the seed value as a base to generate a random number. If the seed value is not present, what is used? You have 0, 1, a random number, or the system current time. So the answer is actually D, the system current time. So if you guys remember from the beginning of the lecture, it was mentioned somewhere. Yep. So by default, the random number generator uses the current system time. If you don't specify a seed. So that's the answer to this quiz question here. It uses the current system time. So before I move on, does anyone have any questions about what we've gone over so far with Python's random module? All right. So next is Boolean. The Boolean data type has only two values, true and false. The Boolean expression is an expression that can be evaluated to true or false. So let's go to this website a bit to understand the operators that help form a Boolean expression. I think we might have stopped by this website a while back, actually, in an earlier lecture. Yes, we did. So these operators, for example, well, maybe not, but these operators right here are all Boolean operators, like double equals and not equal, greater than, less than, greater than or equal to. These were all Boolean operators because they return a true or a false value. Whoops. So let's look at this table and tell me if the result is x is equal to true or y is equal to false. So let's see, if the operation is x or y, the result is if x is false, then y, oh, this is kind of, okay. So this is kind of a confusing way to put it, but the main thing to get out of this slide is that with the OR operator, if one of the variables are true, in this case, if x or y is true, then the whole expression is true. With the AND operator, if x or y is false, then the whole thing is false. And with the NOT operator, if x is true, then the output is false, and then vice versa. That's the main thing to get from this slide. Let's see, now we have a Boolean value from comparison. We have the less than, which is strictly less than. You have less than or equal to, greater than or equal to. These are all things that you guys may have experience from just in your math classes. I guess the three things to keep in mind are there are four things to keep in mind down here. So the double equal sign here is just that two numbers are equal to each other, two variables are equal to each other. This exclamation point followed by an equals is not equal. And then Python also supports is and is not, which does exactly what it means. It compares if the variable on the left, let's say x, is equal to the variable on the right, which is y. And it does this object-wise, which we can think of as being a little bit more sophisticated than the regular equals that Python does with the double equal sign. So are there any questions about Booleans so far? All right. Now, The bool function allows us to evaluate any value and return true or false. So let's try it. So let's give these a try. Oh, oops. So we have print bool Python, print bool 5, and print bool 8. So this is all going to return true. Oh, except the last one. I thought that was a 10 for some reason. So, yep. So the first two give us, so bool Python and bool 5 give us true, and bool 0 gives us false. Now, the reason for this is because in Python, the existence of something always gives true, while 0 always gives false. And I think that's talked about in the, yeah, it's talked about in the slide too. So in Python, almost any value is evaluated to true if it has some sort of content, but value none is evaluated as false. So that means any string is true except empty strings. Any number is true except for 0. Any list, tuple, set, and dictionary are true except empty ones. So that's how the bool function works. So we have a quiz. Can you guys tell me what not true and true will give? Will that give a true or false? Okay, let's break this down. So true, so remember that the AND operator in Python, oh, let's see, we have an answer. Okay, returns false, that's one answer. So remember that the AND operator in Python returns true only if both the left and right is true. So in this case, it returns true. So now we have not true, and not true gives us false because not always gives the opposite of what it's given. So good job, Henry. Now, can somebody tell me what true or false will give us? Yep. True or false will give us true because with an OR operator, as long as one of the variables are true, then the whole thing is true. Now, can somebody tell me what not false and true will give? Will that give true or false? All right, so false and true gives false because of this false right here. So now we have not false, and not false gives true. So this whole expression here evaluates the true. Now, okay, now the last question, false and false. Now this one is a bit tricky, but can someone maybe tell me what false and false will give? So false and false will still give false because as long as even one variable is false, then the whole thing is false. Let's see, we got some more. Okay, so I'll ask you guys this in simple terms. Which number is, I'll ask you guys this. Is 3 greater than 4? Is that true or false? Yep, that's false. 3 is not greater than true. 3 is not greater than 4. And the opposite of false is true. So this whole thing, not 3 greater than 4, will evaluate to true. Now we have not 1 and 1. So remember that in Python, any number that's not 0 will always give you true. So we could think of this as being like not true and true. So true and true gives true, and not true gives false. So this whole thing here, this whole second one gives false. This third one. Now, can somebody tell me, is 9 less than 0? Yep, that's false. And can somebody tell me, is 0 less than -9? So that's false. 0 is not less than -9. So false and false gives us false. So this whole third expression evaluates the false. Now we have 9 is greater than 0, which is true. And then we have true or false, which is true because of the or. So this last one evaluates to true. So Boolean expressions are very, very important when we get to if statements in Python, because if statements are kind of built on this kind of logic. So you guys may refer to this content when we get to if statements again. All right. So we have 2 problems for the homework. The first problem, we know that the colors can be defined using the RGB system. RGB values can be an integer between 0 and 255. Use random to generate 3 values for RGB respectively. Go to a color picker to see what color it is, plus submit a screenshot. Then use math to find the factorial of the red value and the floor division of green over 5. So some randomness and some math stuff in this homework. Any questions about it, just from this explanation here?
How will we, like, what will the color picker be? What website?
You could choose any color picker website. So if I were to just Google color picker, let's see. I wonder if this has an easy way of, okay. So you could change the RGB value here, it looks like. So you're gonna get 3 random values. So you could just go to just Google color picker and then go to RGB, the one that's to the left here, and then just type in your values and you should get your color, and then just take a screenshot of your answer. But you can use any website that you want. Any other questions? All right. Now the second problem, say that there are 100 different colored candies in the bag. You're allowed to reach in and grab 10 of them. 70 of the candies are red, 20 are green, and 10 are blue. Simulate a possible grab. How many of each candy did you get? Take a screenshot and submit it. So hint, you'll have to use the random function that lets you assign weights to a sequence. So just a little hint there. Any questions about this problem? Right, this was the last slide. Are there any questions about the content that we have gone over today? Okay. Well, it's about 7:20. I guess in honor of spring break, I'll let you guys go a little early today because we've gone over everything that we've needed to gone over for lecture 3. So if no one has any questions, you guys can have a good rest of your evening. I'll post the code onto the Google Classroom so that you guys can use that as reference. Yeah. No questions? Okay. I guess we guys can go if you don't have any questions you need to ask. Any questions, Ivy?